Hi, welcome to my channel pibyme Maths. This is by WST02. Here we are solving May-June 2022 Statistics 2 paper. So let's look at question number 1. The independent random variables W and X have the following distributions. W follows a Pearson distribution, X follows a binomial distribution. Write down the variance of W. In Pearson distribution, mean is equal to lambda is equal to variance. So it is equal to 4 because lambda is 4, right? So just a one more question. So you don't need to write mean is equal to, you can write lambda is equal to 4 or simply you can write 4. B now. Determine the mode of X. Here the mode is basically the value of X with the highest probability. So you need to find the probability of X is equal to 0, X is equal to 1, X is equal to 2, X is equal to 3. And check which one has the highest probability. In Pearson distribution, the formula is this: NCX P power X Q power N minus X, right? P is 0.8, Q is 0.2. So when you put 0, it's going to be P power 0, it's going to be just 0.2 whole cube. This is 3C1, 0.8, 0.2 square. 3C2, which is also 3, 0.8 square, 0.2 cube. Here 3C3, which is 1.8 power 3, 0.2 power 0. You need to find out which one has the highest probability. 0.2 cube is 0.23. Did I put 0.2 to the power 3 is okay, that's the least one, 0.008, and the second one is 3 times 0.8 times 0.2 square is 0.096. And then when you find the last one, 0.512. Let's say you calculated this first, X is equal to 3. This is already more than half. So all these probabilities, if you add all these probabilities, you are going to get 1 minus this. You are going to get 0.488. So this is the highest probability, right? So you can write therefore mode X is equal to 3. The corresponding value of X, not the probability, the corresponding value of X is the mode. Otherwise you need to calculate this also, this value also, and check which one has the highest value. But you need to do it fast, it's just a 2 mark question. One observation from each distribution is recorded as W1 X1. Find P of W1 is equal to 2 and so multiply X1 is equal to 2. Apply the formula. W is a Pearson distribution, so e power minus lambda, lambda power 2 by 2 factorial. Here it's binomial 3C2 P power 2 Q power 3 minus 2. Let's calculate this. E to the power minus 4 times 4 square over 2 factorial is just 2 times 3C2 is just 3, 0.8 square times 0.2, 0.5626, 0.05626 dot dot dot. You can also round it to 3 significant figure, 0.563. That's all. Just a 3 mark question. Let's move on to part D now. Part D, find the probability where X1 is less than W1. Okay, W1, X1 follows binomial distribution and the values X1 takes are 0, 1, 2, 3, right? Because N is equal to 3. For W and lambda is 4, so W can take it as W. 0, 1, 2, 3, 4. Now you need to take the take all the combination of numbers where x1 is smaller than w1. So when will the x1 be smaller than w1? When x1 is 0 and w1 can be anything greater than 0. Instead of taking these combinations 0, 1, 0, 2, 0, 3 and add them, you can write this way. That would be a lot easy. Plus, when x1 is equal to 1 and w1 is greater than 1. When x1 is equal to 2 and w1 is greater than 2, x1 is equal to 3 and w1 is greater than 3. You see how I am writing the property. We can write this as p of x1 is 0 times w1 is greater than 0, which is 1 minus w1 is less than or equal to 0, right? Plus p of x1 is equal to 1 times p of w1, 1 minus p of w1 is less than or equal to 1 when you rewrite that, plus p of x1 is equal to 2 times 1 minus w1 is less than or equal to 2, plus p of x1 is equal to 3 times 1 minus p of w1 is less than or equal to 3. We need to find these properties. Good that we have calculated these values in part A. All the 4 properties, we can make use of them here. So what I'm going to do now, p of x1 is 0. We calculated the property here, which is 0.008, right? Don't use the rounded figure, use the actual figure. 0.008 times 1 minus, for this value, its w1 is equal to 0. I'm going to use the table for these cumulative frequencies because lambda is 4, right? So we can use the table. Go to table, Pearson cumulative distribution. Lambda is 4, that's the 8th column. Take the value x is equal to 0, which is 0.0183. 0.0183 plus p of x1 is equal to 1. We calculated the property here, 0.096. 0.096 times 1 minus the value for x is equal to 1, 0.916. Plus x is equal to 2. We haven't calculated the value x is equal to 2. Let's do it quickly. That's going to be 0.3 times 0.8 square times it should be 0.2 to the power 1 actually. 0.2. Sorry, this is 3, right? I put 0.3. It should be just 3. So 0.384. This value is 0.384. So here 0.384 times 1 minus x is equal to 2, the cumulative value 2381. 0.2381 plus this property x is equal to 3. We calculated it as 512. 0.512 times 1 minus the highlighted one from the table, 4335. 0.4335. Now we need to carefully simplify this. So let's put everything in the calculator. 0.008 times 1 minus 0.0183 plus 0.096 times 1 minus 0.0916 plus 0.384 times 1 minus 0.2381 plus 0.512 times 1 minus 0.4335. 677 0.6776 round it to 3 significant figures 678. That's all. Question number 2 now. The time in minutes spent waiting for a call to a call center to be answered is modeled by a random variable t with probability density function this. Use algebraic integration to find in minutes and seconds the mean waiting time. The mean waiting time is E of t. The formula is sigma t times f of t dt. So integral, the limit is 0 to 4 t times, write the f of t here, t cube minus 48t plus 128 dt. You can keep 1 over 198 outside, so 0 to 4, take t and multiply everything. So you're going to get t power 4 minus 48t square plus 128t dt. It's going to be 1 over 192 times t power 5 over 5 minus 48 t power 3 over 3 plus 128 t square over 2, 0 to 4. We need to calculate this value. Okay, so what I'm going to do, they want the answer in minutes and seconds. Okay, so simplify this first. 1 over 192 t power 5 over 5 minus 48 over 3, 16 times 3 or 48, 16 t cube plus 64 t square. So we are dealing with a bit smaller number in this case when you simplify. 192. We don't need to sub in lower limit because everything becomes 0 when you sub in the lower limit. Just sub in the upper limit. 4 power 5 over 5 minus 16 times 4 cube plus 64 times 4 square. So let's calculate this. Let me try to put everything in the calculator one shot. 192 times 4 to the power 5 over 5 minus 16 times 4 cubed plus 64 times 4 square. 16 over 15, okay? But the question clearly says they want the answer in minutes and seconds. So what you need to do, you need to change it to decimal. 1.0666. That means 1 minute, 0.666, right? You need to change it to seconds. So what I'm going to do, I'm going to put minus 1, I get this, times 60 will give us the second, 4 seconds. So the answer is 1 minute, 4 seconds. That's the answer. The answer is 1.0666. Don't write it as 1 minute 06 seconds. That's wrong. This is 0.6 minute. 0.666 minutes actually. You need to change it to seconds by multiplying by 60. Part B now. Show that P of 1 to 3 is equal to this. So we need to integrate the function from 1 to 3. 1 over 192. Take the function t square minus 48 t square minus 48t plus 128. That's all. T cube, right? T cube dt. So what I'm going to do, I'm going to keep 1 over 192 outside. When I integrate t power 4 by 4 minus 48 t square over 2 plus 128t 1 to 3. Can write one more step. 1 over 192 t power over 4 by 4. This is 48 over 2 is 24t square. 128t, 1 to 3. Let's sub in the upper limit first. 3 power 4 by 4 minus 24 3 square plus 128 3, that's upper limit, minus the lower limit. When you replace t by 1, it's going to be 1 over 4 minus 24 plus 128. Let's calculate this value now. Okay, 3 to the power 4 over 4 minus 24 3 square plus 128 3. Take minus and multiply by everything by minus, so it's going to be minus 1 over 4 and then positive 24 negative 128. Get this answer, divide by 192. 7 over 16. That's all, just a 3-mark question. 7 over 16. Part C now. A supervisor randomly selects 256 calls. Use suitable approximation. Because n is large, we need to apply the suitable approximation. What is P here? Find the probability that more than 125, that's what we need to find the probability about, of these calls take between, this is the probability, P of, this is the probability of success, between 1 to 3, which we calculated in the previous part, right? 1 to 3, this is what we calculated here, 7 over 16. Okay, so we can write X follows binomial distribution of 256, 7 over 16. Here n is large, P is small, but okay, 7 over 16 is close to 0.5, so we are going to apply normal approximation. N is large, P is close to, you don't need to write this line actually, it's just, I'm just showing this. So mu is NP, which is 256 times 7 over 16. Sigma is square root of NPQ, square root of 256 times 7 over 16 times Q is 1 minus P. Get these values first. 256 times 7 over 16, 112. Take 112, multiply by 1 minus 7 over 16, that's going to be the variance 63, so sigma is square root of 63, square root of 63, 3 root of 7, or keep it as square root of 63. So you can write normal distribution, let's use y follows normal distribution of 112 comma sigma square, so write it without the square. They want us to find P of y is more than 125. We need to apply continuity correction first. So P of y is greater than or equal to 125.5. And then apply standardizing the normal distribution. Z is greater than or equal to x minus mu over sigma, and then using the method you learned in S1 normal distribution, get the value of this. So let me calculate it first. 125.5 minus 112 divided by square root of 63, which is, take it as 2 decimal place. P of Z is greater than or equal to 1.70. So let me move on to the next slide. So we need to calculate this. The area on the right hand side of a positive number is same as 1 minus Z is less than or equal to 1.70. Now let's get the table value for 1.70. For 1.70, it's 9,554. 0.9554. So it's going to be 0.0446. That's the final answer. Question number 3 now. A point is to be randomly plotted on the x-axis where the units are measured in centimeter. Okay, let's say this is x-axis. The random variable r represents the x-coordinate of the point on the x-axis, and r is uniformly distributed over the interval -5 to 19. Okay, so let's say y-axis is here. We are taking the interval -5 to 19. So we are plotting the points. We can model this as a uniform distribution from -5 to 19. -5 to 90. So this one, we know this is 1 over b minus a. 19 minus of -5, 19 plus 5 is 24, right? Okay, let's read the question for that. A negative value indicates the point is on the left of the origin. Okay, a positive value indicates the point is on the right to the origin. Part A, find the exact property that the point is plotted to the right of the origin. That means the point is plotted here. So it's basically in uniform distribution, finding the area of this, which is the probability is the base is 19 minus 0 times the breadth of the rectangle is 1 over 24, 19 over 24. That's the answer for part A. Just a 1 mark question. Part B now, find the exact probability that the point is plotted more than 3.5 centimeter away from the origin. Okay, 3.5 centimeter is here. Let's say minus 3.5. This is positive 3.5. So now they are saying the point is more than 3.5 centimeter. So you plot the point anywhere here or here. So the probability is same like finding this area plus this area, right? The distance from the origin is r, right? Okay, so r should be more than 3.5. So it can be on the positive side or left hand side. So when we write it, we need to write, it can be a positive number or negative number. So put it as modulus r is greater than 3.5 is equal to this area, which is 19 minus 3.5 times 1 over 24 plus this area. This area is at the bottom. It's basically minus 3.5 minus of minus 5 plus 5 times 1 over 24. Let's calculate this. That's the area. So 1 over 24 is a common factor, so the denominator will keep it as 24 on top. 19 minus 3.5 19 minus 3.5 and then plus 5 minus 3.5. 17 over 24 is the answer. That's all. Let's look at part C now. Sketch the cumulative distribution. Okay, we know the PDF f of x is 1 over 24, 0 from minus 5 to, we use small r here, not f of x, f of r, to 19 otherwise. You don't need to show the PDF, I'm just trying to explain. To find capital F of x, you need to integrate it. When you integrate this, you're going to get x over 24 plus c. And you can sub in the condition f of 19 is, sorry, f of minus 5 is 0. Minus 5 is the lower limit, right? So we'll get 0 is equal to minus 5 over 24 plus c. C is positive 5 over 24. So the f of x is basically x plus 5 over 24 minus 5 to, oh, it's not x actually, it's r, right? So r plus 5 is 19 0 when r is less than minus 5, 1 when r is greater than 19. This is if they ask you to find capital F of x. But they just want us to sketch the capital F of x. So this is a straight line, right? A straight line, f of r, don't put x. So if you replace r by minus 5, f of minus 5 would be 0. If you replace r by 19, f of 19 is going to be 1, right? So we need to sketch the line. We need to sketch the cumulative. This is small r, this is capital F of r, 0. When r is minus 5, the f of r is 0. So that's the x-intercept. When r is 19, so it's a line with the positive slope. This is 1 when r is equal to 90. That's all. You just show this graph, that's it. You don't need to show any of this working actually. But to find f of x, you need all this. To find capital F of x. Part D now. 3 independent points with the x coordinates r1 and r2 are plotted on the x-axis. Okay. We have x-axis here. On the f of x is here. Gonna take it as r and f of r, 0. Find the exact property that all 3 points are more than 10 centimeter. This is 10 centimeter. The function is this, minus 5 to 90. This is 90. This is minus 5, right? So now all 3 points are more, so that means the first point should be between 10 to 19. So P of R1 is greater than 10. So to find the probability, you need to find the area between 10 to more than 10, right? So that's 19 minus 10 times the breadth. Actually, this will be 1 over 24. So you get 9 over 24. It's the same thing for the second point also. R2 is greater than 10, 9 over 24. P of R3 is greater than 10, 9 over 24. Now when they say all 3, P of all 3 points are greater than 10 centimeter away, you need to multiply all 3 probabilities, which is same as 9 over 24 whole cube. 9 over 24 whole cubed, which is 27 over 512. That's the answer. Let's look at double line now. 3 points with x coordinate r1, r2, r3 are plotted. Now don't take this condition, okay? Now 3 points are plotted. Find the probability that the point furthest from the origin is more than 10 centimeter. That means out of these 3 points, at least 1 point should be between 10 to 90. That's what it says. The point furthest from the origin is more than 10 centimeter. So we need to find at least 1 point is greater than 10. Right? Or it's same as P of R is greater than 10. Which is same as 1 minus P of R is less than or equal to 10. What does that mean? Instead of finding at least 1 greater than 10, we can find 1 minus all 3 points lies within 10 centimeter. Less than or equal to 10 or 10 centimeter. Okay. In this part here, we calculated all 3 points lies more than 10 centimeter. The answer is 9 over 24 whole cube, right? Why we cubed it? Because all 3 properties are 9 over 24. Now if we are talking about P of R is less than 10, You need to subtract this probability from 1 and then cubic. That's going to be 1 over 9, 1 minus 9 over 24, answer Q. This is basically the probability that all three lies within 10 centimeter. So 1 minus 125 over 512 will give you the answer. 387 over 512. Hope you understand this. When they say the furthest point from the origin is more than 10 centimeter, that means they are saying there should be at least 1 point here out of 3 points. That's all.